Syslog is one of the oldest sources of network telemetry, and while it is widely supported, it has some inherent challenges that make it difficult to use, primarily due to the volume and variety of messages generated. It is not uncommon for a single device to generate thousands of messages a day. These messages are often just sent to a log collector, occasionally used for post-outage analysis. Altair is reinventing how operators manage their networks using AI and machine learning. In this video, we will show you how we use these techniques to Syslog to solve its inherent challenges. Altair starts by ingesting the raw Syslog data. As the messages are processed in the data pipeline, Altair begins classifying them using its library of Syslog profiles, populating the relative dimensions in real time. The classification process enables quick reduction of noise and advanced analytics. For example, rather than filtering through thousands of messages from a device to try and understand what is happening, the operator can reference the Syslog dimensions to quickly see if they're related to a common event, such as a hardware failure or kernel panic. Customers can also build their own classifier profiles for specific dimensions they want to populate and analyze. Additionally, Altair uses machine learning on this data. With this, Altair is able to automatically find Syslog anomalies in the classified dimensions, or with a combination of the Syslog native fields, such as device name, application, and severity. Altair will also correlate the Syslog anomaly to the learned network model, and with other network anomalies and events. The operator is quickly able to see how these anomalies and events are related to each other and the network topology. Finally, these high-fidelity incidents can be sent to your operations platform like ServiceNow or Slack. The details of the ticket include any correlations discovered. As new events and anomalies are detected that are correlated with the existing incident, the ticket is automatically updated. Next, we're going to show real examples of this from production networks. We will start the Syslog demo using Altair Trends. Here, the operator has selected the Syslog view. We're looking at the Syslog messages for the last 7 days across all devices in the network. Additionally, the sample time can be adjusted as seen here. In a quick look at the graph, we can see the network generates about 8 messages on average per 5 minutes. Currently, we are sorted by top talkers. In this view, we can quickly see the top device, facility, application, severity, and even message description. Selecting any of these items will adjust the filter to only show that relevant dimension. In this example, the operator wants to investigate the messages that have a severity of critical. They start by selecting that dimension category. Once that is done, Altair will only display the dimension details for the critical messages. In this view, the operator has actually created new Syslog dimensions and categories using regular expression matching. This is a very powerful feature as operators can use this to create new dimensions of analysis by extracting strings out of the Syslog descriptions. Altair will also use machine learning on these new dimensions and categories, enabling the operator to be notified when an anomaly is detected. In this example, Altair is extracting the BGP peer IP from the Syslog text into a new dimension that can then be used for analytics and anomaly detection. Another powerful review of the Syslog data could be done using the heat map feature. In this view, we're looking at the last 7 days of data and doing a heat map of device name on the vertical axis with application on the horizontal axis. In this view, it becomes very clear that the RPD application on 2 devices are driving the vast majority of the Syslog messages. The heat map view can also be customized by the operator. For example, you could build a heat map of only Syslog anomalies. Once a view is created, it can be added to a dashboard, allowing for quick analysis. Next, we will show examples of Syslog rate anomalies. Altair builds machine learning models based on message attributes such as the device name, application, and severity. In this example, we have an anomaly for a particular application on an ASA. Looking at the historical data, we can easily see why this is an anomaly. The operator can also get a sense of the Syslog descriptions by hitting the plus next to the Syslog text. In this example, we can see that the ASA is denying traffic based on an access control list. In the second example, Altair is doing machine learning on a dimension called root cause that is populated from a library of Altair Syslog classifiers. Looking at the message descriptions, we can see they all contain a similar text string. As messages are processed by Octera, they are classified. In this example, any message containing a certain string is attached to the duplicate TCP send object. Octera machine learning is looking for pattern deviations on that object, and as seen in this example, it detected a sudden spike in them. Finally, the operator might want to see how these anomalies would look overlaid on top of the network topology. Switching to the topology view, the operator can pick what they want to overlay. In this case, they are configuring Octera to display Syslog anomalies. The devices in the network with Syslog anomalies are now in red. As you can see, the operator can then select the red dot to see full context of the anomaly. They can also adjust the time series to see the value over a longer period of time. In this video, we showed you how you can use Octera to analyze Syslog messages using TrendView, and how it will classify a Syslog and use machine learning to detect Syslog anomalies, allowing an operator to focus on what has changed in the network. These Syslog anomalies can also be correlated with other events in the network, like congestion and traffic anomalies, enabling the operator to quickly detect and identify the root cause. Thank you for watching.